Calculating the electrical load for a fitness club involves several important considerations. Firstly, consider the square footage calculation. It's important to determine if the provided square footage represents the total area of the fitness club or only the portion requiring electrical power. If it's the total square footage, multiplying it by 3 may not be necessary. Secondly, regarding heating, the standard unit of measure is British thermal units, or BTUs, or kilowatts. If a 30 kilowatt heat requirement is given, determine whether it applies to the entire club or just the electrically powered area. Thirdly, concerning the water heater, its capacity is typically measured in kilowatts or gallons. When provided with a 10 kilowatt water heater, clarify whether this refers to its power rating or its capacity in gallons. Fourthly, when treadmill motor amperage is reduced, adjust the calculation accordingly to reflect the low power draw. Fifthly, you can subtract show window requirements if they are not applicable to a fitness club's design. Sixthly, when calculating breaker size, always verify the electrical system's voltage. If the system operates at 208 volts instead of 240 volts, the breaker size must be adjusted to match the voltage requirements. Seventhly, when determining wire size, consider the wire run's length and potential voltage drop, which can influence the appropriate wire gauge. Additional considerations include lighting. Ensure that the lighting load is included in the calculations, as it can significantly contribute to the overall electrical demand. Ventilation is also important. Include the electrical requirements of any dedicated ventilation systems like exhaust fans or air conditioning units. Do not forget other equipment. Account for other electrical equipment such as exercise machines, lockers, and showers. It is highly recommended to have a qualified electrician review the electrical design to ensure all aspects are properly accounted for. It's crucial to accurately assess the electrical needs of the fitness club to ensure a safe and reliable electrical system. Calculating an accurate electrical load requires a comprehensive understanding of the facility's equipment, square footage, and operational needs. Now let's delve into the specifics of each component, starting with the square footage calculation. The National Electrical Code, or NEC, often uses square footage as a basis for determining general lighting and receptacle loads in commercial buildings. The NEC provides guidelines on the minimum lighting load requirements per square foot based on the type of occupancy. For a fitness club, it is crucial to determine the specific occupancy type according to the NEC, as this will influence the load calculation. If the given 3,200 square feet represents the total area, you'll need to refer to the NEC tables to find the appropriate volt amps per square foot for a fitness club or similar commercial space. If only a portion of the club requires electrical power, you would only use that area in your calculation. This is particularly relevant if some areas are non-electrified or have minimal electrical demand. Next, consider the heating load. Heating systems can be significant energy consumers. To calculate the electrical load for a 30 kilowatt heating system, you must ensure you have the correct voltage rating for the equipment. If the system is rated for 240 volts, the current draw can be calculated using the formula power equals voltage times current, or amps, where power is in watts. Since 30 kilowatts is 30,000 watts, you can rearrange the formula to solve for current, which gives you current equals power divided by voltage. Therefore, the current equals 30,000 watts divided by 240 volts. This will give you the amperage required by the heating system. If the heating system uses a different voltage, such as 208 volts or 480 volts, you must adjust the calculation accordingly. The type of heating system, such as electric resistance heating or heat pumps, can also affect the load calculation. Electric resistance heaters draw a steady current, while heat pumps may have different load profiles due to compressor operation. In regards to the water heater, the electrical load calculation for a 10 kilowatt water heater follows a similar process. Using the formula power equals voltage times current, you can calculate the amperage draw if the voltage is known. For example, if the water heater is rated at 240 volts, the current equals 10,000 watts divided by 240 volts. This will give you the amperage required by the water heater. Additionally, consider the duty cycle of the water heater. It might not operate continuously, which could allow for demand factors to be applied according to the NEC. Demand factors are percentages that reduce the calculated load based on the likelihood that all equipment will not operate at full capacity simultaneously. Now, regarding the treadmills, if the treadmill motors are reduced to 12 amps, you can recalculate their total load. If there are 8 treadmills, each drawing 12 amps at a certain voltage, the total amperage can be found by multiplying 8 by 12 amps. Then, use the voltage rating to determine the total power consumption. For example, if the treadmills operate at 120 volts, the power consumption for each treadmill is 12 amps times 120 volts, which equals 1440 watts, or 1.44 kilowatts. Multiply this by 8 to get the total power consumption for all treadmills. It is also important to consider the immersed current of the treadmill motors. Motors typically draw a higher current when starting, which can affect the sizing of the breakers and conductors. The NEC provides guidelines on how to account for motor inrush currents in electrical calculations. You can deduct the show window requirements if they are not applicable to the fitness club. Show window loads are typically calculated based on linear feet of the window. If the fitness club does not have a show window or the area is not used for display purposes, this load can be omitted from the calculation. Now, when calculating the breaker size, you must consider the total calculated load and apply any applicable demand factors. The breaker size should be selected to protect the conductors and equipment from overcurrent. The NEC provides tables that specify the allowable ampacity of conductors based on their size and insulation type. The breaker should be sized no larger than the ampacity of the conductors it protects. Also, consider the voltage drop. Voltage drop occurs when the voltage at the end of a conductor is lower than the voltage at the source due to the conductor's resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a certain percentage of the source voltage. To minimize voltage drop, you may need to increase the size of the conductors. For the additional considerations, you must account for lighting. Lighting loads can be calculated based on the square footage of the fitness club and the type of lighting used. The NEC provides guidelines on the minimum lighting load requirements per square foot for different types of occupancies. You must also consider the type of lighting fixtures, such as fluorescent, LED, or incandescent, as they have different power consumption characteristics. You must also account for ventilation. Ventilation systems, such as exhaust fans and air conditioning units, can have significant electrical requirements. The nameplate on the equipment should provide the voltage, amperage, and power consumption. These values should be included in the overall electrical load calculation. Finally, you must consider other equipment, such as exercise machines, lockers, showers, and any other electrically powered devices. Gather the voltage, amperage, and power consumption information for each piece of equipment and include it in the calculation. Remember, it is always a good practice to consult with a qualified electrician or electrical engineer to review the electrical design and ensure that all aspects of the electrical system are properly accounted for. They can help identify any potential issues and ensure that the system meets all applicable codes and standards. In summary, calculating the electrical load for a fitness club requires a detailed assessment of all electrical equipment, lighting, ventilation, and heating systems. Understanding the NEC guidelines and applying demand factors appropriately can help ensure an accurate and safe electrical design. Ensure you consult with a qualified electrician or electrical engineer to review the design and ensure compliance with all applicable codes and standards. This will ensure the safety and reliability of the electrical system for the fitness club. When calculating the electrical load for a fitness club, it's important to go through a systematic process to ensure all factors are considered. Let's review the key steps involved in this process. The first step is to gather all necessary information. This includes the square footage of the fitness club, the electrical ratings of all equipment, and any specific requirements or codes that apply to the location. You should also have a detailed list of all electrical loads, including lighting, heating, ventilation, and equipment. Next, calculate the general lighting load. The NEC provides guidelines for determining the general lighting load based on the square footage of the space. These guidelines specify the minimum lighting load requirements per square foot, which can vary depending on the type of occupancy. Determine the applicable load for the fitness club and multiply it by the square footage to obtain the general lighting load. For receptacle loads, the NEC also provides guidelines for calculating receptacle loads based on the type of occupancy. These guidelines specify the minimum number of receptacles required per square foot, as well as the load associated with each receptacle. Determine the applicable requirements for the fitness club and calculate the total receptacle load. After that, calculate the HVAC load. Heating, ventilation, and air conditioning systems can be significant electrical loads. Obtain the electrical ratings of all HVAC equipment and add them together to determine the total HVAC load. Consider any demand factors that may apply to HVAC equipment, as they may not operate at full capacity at all times. In terms of equipment loads, identify all electrical equipment in the fitness club, such as treadmills, weight machines, and other exercise equipment. Obtain the electrical ratings of each piece of equipment and add them together to determine the total equipment load. Consider any diversity factors that may apply to equipment, as not all equipment may operate simultaneously. Calculate any other loads. Identify any other electrical loads in the fitness club, such as water heaters, signs, and other miscellaneous equipment. Obtain the electrical ratings of each item and add them together to determine the total other load. You must also consider demand factors. Demand factors are percentages that can be applied to certain loads to account for the fact that they may not operate at full capacity at all times. The NEC provides guidelines for applying demand factors to various types of loads. Determine the applicable demand factors for each load and apply them accordingly. Determine the total calculated load. Add all the individual loads together, including the general lighting load, receptacle load, HVAC load, equipment load, and other loads. This will give you the total calculated load for the fitness club. Size the service and feeder conductors. Based on the total calculated load, determine the appropriate size of the service and feeder conductors. The NEC provides tables that specify the allowable ampacity of conductors based on their size and insulation type. Ensure that the conductors are sized to carry the total calculated load without exceeding their ampacity. You must also select overcurrent protection devices. Select the appropriate overcurrent protection devices, such as circuit breakers or fuses, to protect the conductors and equipment from overcurrent. The overcurrent protection devices should be sized no larger than the ampacity of the conductors they protect. Now, consider voltage drop. Calculate the voltage drop in the conductors to ensure that it does not exceed acceptable limits. The NEC recommends limiting voltage drop to a certain percentage of the source voltage. If the voltage drop is excessive, you may need to increase the size of the conductors. Check compliance with codes and standards. Ensure that the electrical design complies with all applicable codes and standards, such as the NEC and local building codes. This may involve obtaining permits and inspections from the local authorities. Finally, have the electrical design reviewed by a qualified electrician or electrical engineer to ensure that it is safe and meets all applicable requirements. They can help identify any potential issues and ensure that the system is properly installed and maintained. By following these steps, you can accurately calculate the electrical load for a fitness club and ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. Remember to consult with a qualified electrician or electrical engineer for assistance with any complex or unusual situations. When performing electrical calculations for a fitness club, it's essential to understand the specific requirements and considerations that apply to this type of facility. Let's discuss some key factors to keep in mind. Firstly, consider the high-intensity lighting. Fitness clubs often have high-intensity lighting to create an energetic and motivating environment. This can result in significant lighting loads, so it's important to accurately calculate the lighting load based on the type and quantity of lighting fixtures used. Second, account for the heavy equipment. Fitness clubs typically have a variety of heavy equipment, such as treadmills, elliptical machines, and weightlifting equipment. These machines can draw significant amounts of power, so it's important to account for their electrical loads in the calculations. Third, keep in mind the HVAC systems. Fitness clubs require robust HVAC systems to maintain comfortable temperatures and air quality. These systems can be significant electrical loads, so it's important to accurately calculate the HVAC load based on the size and efficiency of the equipment. Fourth, consider the audio and visual equipment. Fitness clubs often have audio and visual equipment for entertainment and instruction purposes. This equipment can draw additional power, so it's important to account for its electrical load in the calculations. Fifth, don't forget about the specialized outlets. Fitness clubs may have specialized outlets for equipment such as tanning beds or saunas. These outlets may have specific voltage and amperage requirements, so it's important to ensure that they are properly accounted for in the electrical design. Sixth, remember to consider the occupancy factors. The occupancy of a fitness club can vary throughout the day, which can affect the electrical load. Consider the peak occupancy times and adjust the calculations accordingly to ensure that the electrical system can handle the maximum load. Seventh, review the power quality. Fitness clubs may be susceptible to power quality issues, such as voltage fluctuations and harmonics, due to the operation of heavy equipment. Consider installing power conditioning equipment to mitigate these issues and protect sensitive electronic equipment. Eighth, always adhere to safety requirements. Electrical safety is paramount in fitness clubs, where there is a high risk of electrical shock due to sweat and moisture. Ensure that all electrical equipment is properly grounded and that ground fault circuit interrupters, or GFCIs, are installed in wet locations. Ninth, ensure compliance with the Americans with Disabilities Act, or ADA. Ensure that the electrical design complies with the ADA, which requires that electrical outlets and switches are accessible to people with disabilities. This may involve installing outlets and switches at a specific height and location. 10th, it's best to consider future expansion. Consider the potential for future expansion when designing the electrical system. This may involve installing spare capacity in the electrical panel and using larger conductors to accommodate future loads. Finally, consult with experts. Consult with a qualified electrician or electrical engineer to ensure that the electrical design is safe, reliable, and compliant with all applicable codes and standards. They can provide valuable insights and recommendations based on their experience and expertise. By keeping these considerations in mind, you can ensure that the electrical system for a fitness club is properly designed and installed to meet the specific needs of the facility. This will help ensure the safety, reliability, and efficiency of the electrical system for years to come. Remember to prioritize safety and compliance with all applicable codes and standards.